Okay, so this is the final part for your summer assignment and review. If I feel like there's another video that I need to put up to kind of help with a couple more things that'll help you with the first couple weeks of school, I will do that. If you have any requests, also just message me and let me know. But this will be the part 4. I'm going to start with solubility rules since number 23 is based off of that, and then we'll finish the whole video with number 22. So to start us off, you guys were provided this little chart right here, this one right here. And so you are more than welcome to look through this and find your own way to memorize it. As you can see, they gave you these little things, right? So AP honors, CBS, PM, CBS, PBS, right? And so if that works for you, by all means, please use that. You basically just need to find the way that works best for you. This chart over here was what you guys had back in pre-AP year. You will not be allowed to use this chart. I am just giving you the warning. I might be nice for 1 or 2 days, but after that, you are not to use that anymore. You do have to have these rules memorized. They play an important role in quite a few of our different topics that we're going to cover this year. So it's important that we know the basics, just like on the polyatomic ions. As long as you've got those 32, you're in a good spot. The couple others will come from experience, right? So same here. As long as you got the general rules, the couple exceptions that are kind of weird that just need to be memorized will come with time and experience over the course of the year. So what I want to remind you of is on this chart from pre-AP year, you had 2 categories, okay? We had soluble categories and soluble category, and we had the insoluble category. And so the way I told you guys to do this is to read it kind of out loud. And you would say nitrates are soluble unless, and you would look to see what's on that side, okay? And for this, nitrates are basically always soluble, okay? And then for the insoluble, you would say carbonates are insoluble, as in they form a precipitate, right? So 2 liquids come together and you get a solid at the end, right? So carbonates are insoluble unless they are joined with ammonium or any of the alkali metals, or group 1, right? That's group 1. So this was the way that you used to use the chart. And so just know that this next little method that I'm going to show you, it includes most of these. The exception that it does not include is going to be your carbonates and your hydroxide. So those 2 are ones to kind of get to know, all right? And as you can see, they both got this ammonium, makes them all of a sudden soluble. So ammonium, as you can see from the top, always is soluble, right? So that's worth memorizing. Remember your alkali metals, that's your group 1, and this we're going to learn in the video that I'm going to show you is a Castro bear, okay? So we're just kind of keep that in mind. All right, so the video that I recommend, and I will put a link up for this, is this one that shows you nag-sag, all right? And this is what the cover of it looks like, so I just wanted you guys to have that so you can see that. I would take a second and just watch it over and over, all right? But in the end, on this video, oops, my bad. Let me see if I can, nope, all right. So in the video, I was gonna see if I could scroll to the end, but can't do that. So what we're gonna do is I will give you the rundown of it. So you can kind of see this little part, and that's the basis of it, all right? So nag-sag stands for nitrates, acetates, group 1, sulfates, ammonium, and group 17, okay? So as long as you can remember those, you're in a good spot. The 2 exceptions that I want you to know to nag-sag, so I'm just gonna put nag-sag, you have the key off to the side, right? Okay. But you have 2 exceptions. So these guys are always soluble, except, and you have these 2 rules. You have the PMS rule, okay? Okay, so the PMS rule, sorry, I had to chop my video for a second. My son came in. PMS rule stands for lead, mercury, silver. Okay, and this is going to apply to, let me erase this arrow because that is not in the right spot. All right, so this rule is going to apply to your sulfates and your group 17. So anytime you have lead sulfate or mercury with the sulfates, or any of those with your group 17, the halogens, okay? Those are going to cause precipitates, all right? The second rule you're gonna learn is called Castro bear, okay? So I'm gonna write out the name first, right? So we have Castro bear rule. And what that stands for is calcium, strontium, barium, okay? Calcium, strontium, barium, anytime they are mixed up with a sulfate, are also going to form your precipitates, okay? So if you can remember this little nag-sag trick, okay, so all nitrates, all acetates, all ammoniums, right? These guys have no exceptions, all group 1s, okay? Those guys, you'll be set, and you'll at least be able to recognize it. You'll recognize that with sulfates in group 17, you do have these 2 extra little exceptions, okay? And like I said, the thing that this does not cover is going to be your carbonates and your hydroxides, which tend to be insoluble except when they have ammonium, right? So we have our ammonium rule, which already trumps it, okay? And your alkali metal, your group 1. So that one takes care of your carbonates, all right? So that one's pretty easy. But other than that, all your other carbonates are gonna be insoluble. Hydroxides, once again, go with ammonium and your alkali metals. So those 2 rules are already accounted for. And then finally, Castro bear applies to that. So Castro bear kind of works opposite and makes it now soluble. So if you have calcium hydroxide or strontium hydroxide, barium hydroxide, those are now going to be soluble things. Other than that, these guys are insoluble. Okay, so make sure you take a look at your 2 lists, kind of get to know them. It's not too bad. Just find the way that makes sense to you the most. All right, so now that we've got that, we're going to predict the following to be soluble or insoluble. When you are asked to do this, you are doing a double replacement, okay, a double replacement. And I might try and put up a video reviewing your different types of reactions again, so that you'll be ready to go that first week of school in predicting your reactions, okay? That'd be a good thing to review if you still have your notes. All right, but a double replacement, if you remember, was something that looked like this. So we had AB plus CD gave you AD plus CB, right? Okay, so we basically just swapped partners. So when we look at that and the problems that they're giving us, right? Let me shrink this up. Okay. When we're looking at the problems, we have the first one is potassium nitrate. So nitrate tells me that this is going to start off aqueous, right? Plus barium chloride, okay? All of group 17 is always going to be soluble. So there we go with that one. We're going to yield, we're going to switch partners here. So now I'm going to have potassium chloride plus barium nitrate. And make sure you throw the 2 on the outside. Barium has a +2 charge and that gets swung over. Nitrate is a -1, okay? All right, now what you do at this point, you do not need to balance it unless you, once again, would like to practice that, and you can check your answers with me if you'd like. But what you're going to look at now is your products, and do they fall under any of those categories for the solubility rules. So here we have a group 1 and a group 17. this is definitely going to be an aqueous thing, so soluble, okay? Barium nitrate, we have nitrate. Nitrate is always going to be aqueous, so we're going to say aqueous for that one. So therefore, this produced soluble products, okay? So we mix two liquids together, we end with a liquid, okay? That's what that means. All right, the next problem, letter B, we have sodium sulfate plus lead, and you recognize what kind of lead it is by looking at that little subscript right there, reverse crisscross, right? So this will be lead 2 nitrate. We're going to swap partners, so now I have sodium nitrate plus lead, don't forget he's a +2, sulfate is a -2, so these guys cancel out. So we just said PbSO4. All right, so this one is a nitrate rule, so this is definitely soluble. Oops, let me go ahead and put aqueous here. And over here we have lead sulfate. So we got to think about what rule does lead fall under. Lead is that PMS rule, right? So the PMS rule. And if you remember, PMS rule went to sulfates in group 17. Well, look what we've got. We've got a sulfate. So we're going to say solid for this guy. Okay, so this is going to be insoluble. All right. Let me give myself a little bit of room here. Okay, and then finally, we'll end with the last one, which is potassium hydroxide plus iron. Again, you recognize what kind of iron it is by looking at that little subscript across. You reverse crisscross these. You have iron 3 nitrate. Okay, we're going to switch partners. So we have potassium nitrate, and we'll have iron 3 hydroxide. Okay, so looking here, my nitrates are going to be aqueous. Hydroxides, remember, are going to be insoluble unless they're with Castro, ammonium, or group 1. Iron is not any of those. So this is going to be a solid, and this will be an insoluble product. Okay? So that's how you use your little, your solubility rules. Make sure you review those. If you would like a couple extra things, you can either Google. There's a lot of practice problems out there that you can use, or you can ask me, and I'll send some your way. Okay. The last thing, so this is it for the summer assignment. Yay! Okay, so number 22 was a dilution problem. And so it's going over molarity. I do want to take a second to remind you what molarity is. Molarity is a measurement of moles of solute per liter. Okay, moles per liter. It's not per milliliter, it is per liter. So, the key thing here is making sure your volume is in liters, making sure your units are in moles for the top guy, okay? When you are solving for dilutions, okay, you can kind of see the M1V1 equals M2V2. You're thinking about having a stock solution. Stock solution is the concentrated solution, so you'll see me use brackets a lot. Brackets means concentrated or concentration, okay? And then this M2V2 is going to be the diluted part, okay? And so what tends to happen is we tell you, hey, we want this molarity and this much. You have this kind of molarity to begin with. How much do you need to use, okay? Unfortunately, that's not the problem that I gave you guys on your summer assignment. But that's usually how it's used in the lab area. Okay, so the one that I gave you on your summer assignment says a concentrated hydrochloric acid is 11.7 molar solution. So what is the concentration of a solution made by diluting 25 milliliters to 1,000 milliliters. So what they're telling you here is this is part of stock solution. This is part of your stock solution. What is the concentration? So we want to know what is the diluted concentration by diluting 25 milliliters of the stock solution to 1,000 milliliters, okay? So knowing that, we're going to go ahead and put this into M1, V1, M2, V2. So I'm going to start with my 11.7 molar solution, okay? We have 25 milliliters, so that is equal to 0.025 liters. What I did was I took that decimal and moved it 3 to the left, okay, or divide by 1,000. So 0.025 liters. So that equal to, we want to know the concentration for 1,000 milliliters, which is just 1 liter, okay? So what we've got here is we've got an easy multiplication problem divided by 1. So it's really it was an easy one to give y'all, but hopefully it reminds you on how to do it. So what we end up getting, if you type this in your calculator, is going to be 0.2925 molar, okay? But let's look at our sig figs. So here we had 3, okay? And here we have 1, here we have 3. I'm going to go ahead and go to 3 sig figs for this answer. So I'm going to say 0.293 molar solution, okay? Or 292 would be fine as well, okay? So that's it. Once again, just message me. We are in the countdown now. We've got 2 weeks before school starts. So let me know if you need help. I will let you know by, I would say by tomorrow night, if I can do a quick Starbucks sit-in. I'll be on campus on Wednesday. So message me if you need help.